The glory of the moment captures the mind and the spirit of those who come to the land of the skies. Here in the western corner of North Carolina stands a mountain in the very heart of the Blue Ridge. It's not just any mountain, it's Saluda, a mountain rich in railroad history for over 100 years. Saluda is one of the steepest mainline grades in the United States, with grades over 5% in certain sections. Today, Southern Railway is going to take you down Saluda, put you at the throttle, so to speak. You'll also see the safety inspections and train handling practices that ensure a safe trip down the mountain. Today's trip is on Southern Railway's Belmont Coal Train number 270. This 13,000-ton unit coal train is radio controlled with 4 locomotives at the head and 3 in the remote position. The Belmont unit train runs on a 48-hour cycle, shuttling coal from mines at Andover, Virginia, to Duke Power's electric generating plant at Belmont, North Carolina. On its 620-mile round trip, it must take on Saluda. The Belmont pulls 96 loaded 100-ton aluminum hopper cars. With a tare weight of only 24 tons, these silver sides are a real asset to unit coal train service. Studies show that the aluminum car has a longer service life than a conventional steel car. Add to that the car's ability to carry more coal at a lower rate of fuel consumption. All this makes the silver side truly a winner. On the first leg of our journey, we pass through Asheville, North Carolina. Here, the train gets a thorough going over by mechanical personnel.
As the train comes into the yard, we do our roll-by inspection. This is the best way for us to spot things like flat wheels and loose brake equipment. Once it's stopped, we make our walk-in inspection. We're looking for any defects, anything that needs our immediate attention. We check the train line, piston travel, brake rigging, drive equipment, and of course the brake shoes. The Silver Side was one of the first cars to have the Cobra composition brake shoe, which improves braking control. Also, a standard feature on this car is the empty load brake equipment. We make sure the retainers are in the slow, direct release position. And when that's all done, we're ready to do a brake test.
Belmont Coal Train, are you operating a radio train?
Yes, sir. Southern Carolina 270 operating the radio train, over.
Apply your brakes, please.
270 applying the brakes.
Come ahead.
Once the engineer charges the train line to 100 pounds, he makes a 15-pound reduction. After the exhaust stops, he cuts out the automatic brake valve on the lead locomotive and on the remote units. After waiting 45 seconds, he times any leakage for 1 minute to make sure it does not exceed 5 pounds.
Southern Carolina 270 had a 3-pound brake pipe leakage, over.
3-pound leakage. Is your radio control feed valve cut out?
Radio control feed valve cut out on 270, over.
That's good, Captain.
Then a full service brake application is made. This applies the brakes on each car, and we inspect to make sure they have applied.
Southern Carolina 270, over.
Okay, Belmont Coal Train. Air starting up on the truck.
Southern Carolina 270 understands.
After the test, we make sure that the caboose pressure rises before the engineer cuts in the automatic brake valve on the remote units. This tells us that we have a solid train line and that no angle cocks have been turned.
All this effort guarantees the entire team that the Belmont is safe to take on Saluda.
Real safe on 270.
This mile-long train is on its way to Hendersonville, 20 miles away. En route, near the 10-mile post, the air brakes are checked to make sure they apply and release. When we arrive at Hendersonville, a road foreman of engines boards the Belmont. Southern Railway has a road foreman bring all through freights over this mountain.
One of the first things I do is to make sure that all head-end dynamic brakes are working, because we'll be relying on them going down Saluda. Between milepost 27 and 28, I check the dynamic brake amperage on each head-end unit while we go down to 1.3% grade. We should be getting about 600 amps on each unit.
Southern Road Normal Engine, North Carolina Division, engineer on train 172 over.
Carolina 172 over, engineer.
This here I'd like to compare speed indicators and dynamic brake. Average, please, over.
Engineer 270 understands, over.
Read 600 amps, 24 miles an hour, over.
I have the same reading on the head unit, engineer 270, over.
I understand. Thank you.
Now I've completed my dynamic brake check on all 4 lead locomotives. All the ammeters compare, so I'm satisfied that my dynamic brakes are working properly. We are now pulling into Paces Crossing, about a mile from the crest at Saluda. If we had found any defective dynamic brakes, we would wait right here at Paces until our mechanical people could correct the problem. Once we're stopped, here's where our crews set up the retainers. Retainers allow us to keep our brakes on while recharging the train line during the trip down. For the Belmont, we set the retainers on the 20-head cars to the high pressure position. This keeps 20 pounds of pressure in the brake cylinder during recharging.
With this, our train is ready to take on Saluda. But before we leave, let's join Ray Mooney up at Saluda for a quick review of a little history. Ray?
Folks, the history of this bit of railroad goes back into the 1800s, before it was actually a part of the Southern Railway. The railroad out of Spartanburg reached Tryon in 1877. That's at the base of the mountain on the east side. 2 years later, work resumed to build the railroad over the mountain. It took them less than 6 months to finish the road up and over to Hendersonville, a total of 21 miles. Now, over the years, Saluda has seen its share of train accidents, some worse than others, but operating safety has always been a critical issue on Saluda. By 1903, 2 safety runaway tracks had been installed, one just east of Saluda, the other at Melrose, near the bottom of the steepest part of the mountain. Over the years, these runaway tracks saw a good bit of action, but in 1955, due to improved braking systems and a good safety record, the runaway just east of Saluda was removed. Today, our safety track at Melrose remains in service. The switch for this track is normally positioned to direct an out-of-control train up a grade onto a track covered with sand. Approaching this switch, we have an electronic detection circuit that measures train speed. If a train is under control, this circuit electrically throws the switch to the main line. Our safety record here on Saluda has been quite impressive. Our last fatality was recorded way back in 1940. But we don't just sit on our laurels. We are constantly looking for better ways of operating our trains, not just here at Saluda, but clear across the railroad. Now, folks, that's a Southern Railway tradition.
The Belmont is ready to leave Pace's Crossing, so let's rejoin Melvin Warren for this trip over the Mountain of Challenge.
101 on the air gauge.
Due to the complex procedures required to operate this train safely down the mountain, I take over the controls here at Pace's Crossing. One of the first things I do is to insert a special key to keep the dynamic brake from releasing should we have an emergency air brake application. Normally, if an emergency would occur, the PC switch would cut out the dynamic brakes. But with this special Saluda key, we can keep the dynamic brake on. From Pace's on over to Melrose, the engineer handles all our radio communication with a conductor on the caboose. Normally this trip takes about 20 minutes, but today your trip down with us will take much less as we show you just some of the highlights. Right now we're coming up on the Saluda Depot. We're in Notch 8, running 20 miles an hour. We're still on a 1.4% upgrade headed toward the crest. As we pass the depot, our speed begins to drop off. Before we get on up to the crest, let's look at what will occur with our train. This simulated computer graphic shows us exactly what happens when the Belmont goes over the crest. You've got 12,000 horsepower pulling on the head end on a 3.9% downgrade, and you've got over 13,000 tons of coal pulling in the opposite direction on a 1.4% upgrade. This creates some enormous coupler forces, somewhere over 300,000 pounds, right at the crest. So you can see why keeping the Belmont together under these conditions without a train separation demands some real careful handling. Okay, we're coming up on the crest, and I've got it in Notch 8. As we cross the Main Street crossing, we're at the very crest of Saluda. When the fourth lead unit passes the crossing, I reduce the throttle to run 7. As every 3 to 4 cars pass the crossing, I gradually notch off the throttle until I finally shut it off.
172 Scaffold Pace's Crossing, 101.
At this point, we're ready to go into dynamic braking. Since the 3 radio units are still coming uphill, dynamic brakes on these units would tend to pull the train apart at the crest. So to keep the coupler forces at a safe level, I put the 3 radio units in idle using the load selector switch. The dynamic brake is applied gradually, bunching the cars as they come over the crest. With our amperage increasing, our speed should come down to around 8 miles an hour. About 4 car lengths below the east end of this siding, I'll make a light air brake application. Using the push button, the air brake is applied for 3 to 4 seconds and then released. This reduces the air pressure on the caboose by 3 to 4 pounds. Right about now, our radio units should be at the crest. As these units pass over the Main Street crossing, they're on a downgrade. So with the mode selector switch, I bring them back online from idle into dynamic braking. At this point, I need to reduce the train line pressure by 3 pounds. This one is a 5 to 6 second air brake reduction.
9-8.
9-8 on the cab.
We're getting close to the 33 mile post off here to the right, and our caboose should be getting close to the crest. Let's listen in.
5 depot, 9-2 on the cabin.
5 depot.
Right now, I make another air brake reduction for a total of 10 pounds. This way we can hold our speed at 8 to 9 miles an hour. As the cab comes under the overhead bridge, I usually make a 3 pound reduction. I've made a total air brake reduction to this point of 12 to 15 pounds.
8-7 on the cab, over the top.
Now I've got this entire mile-long train coming down Saluda. That means we've got over 13,000 tons of coal pushing us down the mountain. With the air brake set, I hold about 600 to 700 amps of dynamic brake, keeping the speed at 8 miles an hour. Okay, the Belmont's coming up on Sand Cut. This is a real sharp curve, in fact an 11-degree curve. To reduce the lateral or side forces on the outside rail, I ease up on the dynamic brake to 500 amps. We are now approaching the field signal at milepost 34.4, and I'm back up to 600 amps dynamic braking. This is the steepest part of the grade, as much as 5.4%.
Carolina 172 got a approach signal. Over.
All right, approach signal.
I must maintain our 8 mile an hour speed as we pass the timing circuit sign here on the signal mast. This is the beginning of the 67-second timing circuit for the safety track. Usually, I have to make an additional 2 or 3 pound train line reduction to hold my 8 mile an hour speed. If I didn't maintain this speed, then we would end up on the safety runaway track.
8-4 on the cab 172, over.
8-4 cab 172, over.
The sign over on the right means we're now leaving the timing section. We've kept the speed right on target, and we should soon get a clear signal down there at Melrose. This will mean we're lined for the main line.
Got a clear signal on the end 172, over.
Cab 172 out.
As we get to Melrose, I hand the controls over to the engineer and then get ready to dismount.
At Melrose, the train is over the steepest and most critical part of the mountain. The road foreman dismounts and makes a roll-by inspection, concentrating on the condition of the brake shoes and rigging. Now the engineer will take the train on around and stop at Fall Creek Trestle. There, the crew will turn the retainers on the first 20 cars back to the slow, direct release position. Then the train can move on to its final destination. With the train down Saluda, the road foreman reports in to the chief dispatcher.
Mr. Will Holland, Melvin Warren, road foreman engine here.
coal train, 270 is down Saluda. Had no problems at all. Yes, sir, everything's just fine.
Saluda, the mountain of challenge. Every day, several times each day, Saluda's winding, steep curves and grades challenges the Southern Railway team to do what it does best, move trains safely. This mountain demands the ultimate in safe train handling skills and procedures. Now, today's trip illustrates just some of these procedures and techniques that have become a hallmark to Southern's long-standing commitment to safe train operations.